Today we're going to start the next chapter, chapter 7. It's going to be chapter 7.1. We're going to talk about similarity. Yes, on that sheet. Take notes on that sheet. So I passed out that sheet, and it's going to go along with my PowerPoint slide today. All right. So today I've got a game. Time to play. Are they similar? All right. Are they similar? First one. Are the fishes similar? Yes, those fishes. Fishies. I said fishies. Are the fishies similar? Yes, they are. Are the trains similar? I hear some yeses, I hear some nos. For reference, so this is a model train. This is a real train. Are they similar? Yes, they are. They are similar. Are the vans similar? The vans are not similar. No, they are not. So as you can see from these examples, the vans are not similar because they've got different shapes. They've got different looks. They've got different colors, right? Whereas the trains, in this example, the trains had the same look. They had the same shape. They had the same dimensions, even though they were two different sizes. Even though this one was about the size of my foot, and this one is hundreds of times bigger than me, they still had the same ratios as far as how they fit together. Okay, so that's what we're going to talk about today with similarity. I want you to pull out that sheet, and we're going to look through and answer these questions. Okay. Number 1. A similarity ratio is the ratio of the lengths of the blank sides of two similar polygons. So my first blank here is going to be corresponding. Corresponding. The corresponding sides of two similar polygons form a ratio. Okay? Two polygons are similar if and only if their corresponding angles are blank and their corresponding sides are blank. Yep, the first one is congruent. So their angles are congruent, but the sides don't necessarily have to be congruent. They have to be proportional. Proportional. Do you guys know what the opposite of pro is? What's the opposite of progress? Yes. My actual math humor for today, though, is what does the 0 say to the 8? Nice belt. The 0 is big, but if you put it slims him up and makes him. Alright, next one. 3. Figures that are similar have the same shape, but not necessarily the same size. You're right. Size. Alright, I want you to look to the figure to the right there, and we are going to name the pairs of congruent angles. Alright, so they go ahead and they tell us these triangles are similar. Can I have a volunteer write down the pairs of congruent angles? I was like, congruent. Go ahead and write it up there. Let's see. Let's just try. Yeah, just go ahead and knock them all out. Okay. So she says angle A is congruent to angle F. Angle B is congruent to angle B. Angle E, right? Alright, so let's fix that real quick. Angle E here. So that's supposed to be angle E. And angle C, you said was congruent to angle D. That was correct. That one is congruent to that. So these triangles are similar, which means our angles are congruent. But what we want to do is we want to talk about number 5. We want to write the corresponding side lengths as a proportion. So when we write as a proportion, we're writing them as fractions. All right. So I want to write a fraction to represent the proportion of the side lengths. Brianne, do you have an idea what we'd put under AB? You can do it. All right, she's saying AB corresponds to FE. That looks good. Pick somebody else for the next one. All right, Caitlin, what side will DE correspond to? All right, and DE corresponds to BC. Well, Caitlin gets to pick. Caitlin, who are you picking? Chloe, you got the last one. What does angle FD correspond to? What does angle FD correspond to? You said AC? You want to write it or you made to? Okay. AC corresponds to AC. Does that look good? So notice here the one on top was always AB or BC or AC. The ones on bottom were FEs and Ds, right? So they relate to their triangle. This triangle was always on the bottom one. This triangle was always on the top part of that proportion. Ready to move on? All right. Oh, okay. Let you get that written down. Next one, number 6 through 9. The first thing I'm going to do is I'm going to circle the correct similarity statement. Notice the little squiggly in between those two triangle statements. That squiggly says similar, right? So remember when we had congruent, we had an equal sign with a squiggly above it. When we're talking about similarity, we can say two triangles or two figures can be similar by putting a squiggly in between them, okay? So that's what that squiggly in between means. So I want to say the correct statement for similarity. In other words, order matters in this case as well, right? Because all three cases are just different ways of rearranging these triangles. So how about I start out by actually doing number 7 first. I think that would actually be easier to write my proportions and then look at that to make my triangle statement, okay? So what could I write out as a ratio of sides? Looking at this figure.
The last one.
The last one.
Oh, sorry. I thought we were on 6.
You're right, but we were doing 7 first.
Oh.
What side is going to relate to what other side of the triangles?
Whose side is going to relate to you? What does that mean? Oh, wait, is it RQ and JK?
RQ and JK.
It's KL.
RQ and JK. Well,
Oh, it's RS.
RS and JK, right. So you have to think about taking this triangle and rotating it 90 degrees clockwise.
I saw the,
So RS, you could say SR, over KJ. That ratio is going to be equal to, what else? What's another pair?
RL to SQ.
JL to SQ. That looks good. But remember, I got to put JL down below because that's where I put the other part of the triangle. Yes. So the last one, right, RQKL. Then when I'm talking about naming them, I want to go in order around my triangle. So if I started with this one, and if I said QRS, I'm going boom, boom, boom. That would have to match up with LKJ. But that's not LKJ, so that's not the answer. All right. So how about RSQ? I go RSQ. That would have to match up with KJL. That looks like a possibility, right? And the last one, QSR. QSR would have to match up to LJK. But that option is LKJ, so that wouldn't be right. So I lied to you, Brienne. Sorry. It is the middle one. I know, I lied. I was just looking too quickly and I got caught up. That's why you do it that way, to make sure you're right. Cool. I got you to the right. It's the right direction. Yeah, thank you. Alright, use the figures for exercise in 8 and 9. I'm going to tell why these corresponding angles and these rectangles are congruent. Yes. Why are the corresponding angles in this rectangle? Why are they congruent? Right? Because all my angles have to be congruent. How do I know they're congruent? Figures 8 and 9. We're looking at the angles, though. They're all right angles, yeah? So since this is a rectangle, since I know this is a rectangle and all the figures are a rectangle, and all the figures in a rectangle are a right angle, then all angles are right angles. Yeah, go ahead. All angles are right angles, therefore all angles are congruent. For you guys unfamiliar with the notation, if you see these 3 dots like this, it stands for therefore. Okay, so I'm using those 3 dots to represent the word therefore. Therefore, all angles are congruent. Cool. So now I don't have to worry about my angles being congruent because they're all 90 degrees. Now I'm just worried about what is similar between these 2 triangles. I'm going to substitute the numbers for the side lengths here. I've got DG over MN. What is DG? Wait, hold on. We're just doing the numbers, the number values. 4 over 5, right? Let me use a different color. 4 over 5. Good. DE over LM. What's... Yep, you got it. 8 over 10, which simplifies down to 4 over 5. Do my ratios equal each other? Okay, that's good, because then I can talk about these 2 rectangles being similar. All right. Any questions over similarity so far? None? We're all good? Okay. All right. Got your homework assignment here.